Today, we're pulling back the curtain on one of the unsung heroes of the digital world, VMware's VMFS data store. You probably never see it, but trust me, it's the powerful, invisible backbone that makes so much of modern IT just work. So let's start with a question that sounds kind of impossible, right? How can you have, say, a dozen different servers all hammering away at the exact same storage drive at the exact same time without everything just grinding to a halt? Or even worse, corrupting all the data? It really sounds like a recipe for total chaos, but it's a problem that's been solved, and the solution is incredibly clever. The easiest way to wrap your head around this is with an analogy. I want you to picture a huge shared digital library. Now, in this library, your physical servers are the librarians, and all your virtual machine files, those are the books. This isn't just any library, though. It's a special one, designed so that all the librarians can grab books, check them out, and put them back all at once without ever getting in each other's way. All right, so let's dive into the magic behind this shared digital library. How does it actually manage to keep everything organized and running so smoothly when there's so much going on at once? Well, the secret sauce is called VMFS. That stands for Virtual Machine File System. And honestly, the name says it all. This thing was built from the ground up for one very specific, very demanding job: handling virtual machines inside a high-performance cluster. This is nothing like the file system you have on your laptop. It's a highly tuned specialist. And the most important word on this slide, it's clustered. That's the key to everything. A clustered file system is fundamentally designed to let a whole group, a cluster, of servers all talk to the same storage at the same time. This is what stops that chaos we were talking about right at the beginning. Okay, so we've got the big picture. Now let's zoom in a little bit. We're going to deconstruct the data store and really look at the pieces that make it tick. So what makes a VMFS data store? Well, a VMFS data store. First, like we've been saying, it's a clustered system. That's non-negotiable. Second, it's built on something called block-level storage. And don't worry, we'll get to what that means in a sec. It's also specifically optimized to handle the huge files that virtual machines are made of. And finally, it basically acts as this neat logical container so you don't have to worry about the complex hardware underneath. It just takes care of all the data about your VMs. And this brings us to that really important distinction: block storage versus file storage. Now, you're probably used to file storage. Think of a shared folder on your network. But VMFS uses block storage. You can think of this as giving the servers a raw, direct pipeline right to the disk. There's no middleman, it's way faster, super efficient, and absolutely essential for the kind of performance that modern virtualization demands. So, how do you actually get from just a raw chunk of storage to a fully functioning home for all your virtual machines? Let's walk through what that process actually looks like. It's really a pretty straightforward four-step process. First, a storage admin carves out a raw piece of storage. It's called a LUN, a logical unit number, and they present it to all the servers. Step 2, that raw LUN gets formatted with that special VMFS file system. Then, for step 3, that formatted chunk of space officially becomes a data store. It's now a single shared pool of storage. And finally, that's it. You can start putting your virtual machine files on there, and all the servers in your cluster can see them and use them. So we've talked about the what and the how, but now we get to the really important part, the why. Why go to all this trouble? The answer is all about the incredible power that this shared access gives you. And this really is the heart of the matter. Having multiple servers see and use the exact same files at the same time isn't just some neat party trick. It is the fundamental building block for some of the most powerful, almost magical features in the entire world of virtualization. And here's the payoff. Because all the servers can see the virtual machine's files, you can do something called a vMotion. This is where you literally move a running computer from one physical machine to another while it's on, with absolutely zero downtime. Think about that for a second. Or what if a server suddenly dies? Well, high availability can instantly and automatically restart its virtual machines on a different, healthy server, because, again, their files are already there on that shared data store. These features are complete game changers for keeping things up and running. But you know how it is with technology, right? It never stands still. VMFS has evolved a ton over the years, and it hasn't just gotten bigger, it's gotten a whole lot smarter. Let's just quickly compare the two versions you'll see most often, VMFS 5 and VMFS 6. Now, they're both great, but VMFS 6 brought a massive leap forward with one feature in particular: automatic space reclamation. And for keeping your storage efficient, this is a huge deal. To understand why, let's go back to our library analogy. So in the old library with VMF5, if you deleted a bunch of books, the shelf space was still technically marked as used until a librarian came around and manually cleaned things up. But with automatic space reclamation in VMF6, the library literally tidies itself up. The moment you delete a file, the system automatically tells the storage array, hey, this space is free now, which keeps everything incredibly lean and efficient without you having to lift a finger. So, as you can see, the VMFS data store is this really foundational piece of tech that solves an incredibly complex problem in a super elegant way. And it leaves us with a pretty big question to think about, doesn't it? As our data, our apps, our entire digital worlds just keep growing and growing, how are these fundamental libraries going to have to evolve next to keep